section 6.3, we're going to be adding fractions and subtracting fractions, but instead of these fractions just having plain denominators, like in the past, like 1/5 plus 2/5, we're going to be having rational expressions as the numerator and denominators. So we'll be seeing variables and polynomials like we've been seeing, but now we're going to be adding them and subtracting them. You can multiply or divide polynomials no matter what they look like. You can take anything in math and multiply it, anything in math and divide it. You don't have to worry about ever having like the same denominator or anything like that. But unfortunately, when you're adding and subtracting fractions, you have to have the same denominator. So if you remember from pre-algebra, to add two fractions like 1/5 plus 2/5, because the denominators are the same, you can just go ahead and add the numerators, and you always keep the denominator the same. So the denominator never gets added or subtracted; it always remains the same, and you just add the numerator. So right here, 1/5 plus 2/5, they have the same denominator, so you add 1 plus 2, and you get 3/5, and then that's your final answer since that can't be simplified. Unlike denominators, though, if you remember, cannot be added together until they have the same denominator. So to find out the same denominator, you're looking at the numbers 8 and 16, and you're actually just trying to find the least common multiple of those two. And then they call it the least common denominator, so that's going to be the number that is a multiple of both. Sometimes you can turn one denominator into the other by multiplying. In this case, you can. We can take 1/8 and turn that denominator into 16 by multiplying everything by 2. Whenever you're doing this, just have to make sure that whatever you do to the bottom, you do to the top as well. So you have to multiply 8 times 2 and also 1 times 2. That turns that fraction into 2/16 instead of 1/8. It's still equal to 1/8. It's just now not simplified. It's 2 times bigger. And now that they have the same denominator, you can add 2/16 plus 1/16 to get 3/16 in the end. So there is no real easy way to do this when we have rational expressions as our numerators and denominators, because like in a calculator, you could just do 1/8 plus 1/16 and then it'll do it for you. We have to understand the process of what happens when we don't have like denominators and how we can change that. So in example 1, adding and subtracting with like denominators should be easier than adding and subtracting without, because we have here the same denominator, 3x here and 3x here, which means all you need to do is you keep the denominator the same, it stays 3x, and you add the numerators. 4 plus 5 is just 9. But then it's very important that once you get your final answer, you simplify it as much as possible. So 9/3x can be simplified. So we can take 9 and 3 and pull out a factor of 3. So if you want to think of it as factoring, we could do like 3 times 3 in the top and 3 times x on the bottom. And this 3 and this 3 will cancel out, and this will end up just being 3/x as the final answer. So after you get to the adding and subtracting part, then just make sure you simplify it. You simplify it by factoring and then canceling things out that are the same in the numerator and denominator. So for this next one, x plus 3 is the denominator for both, which is good. So I know that my final answer will have x plus 3 as the denominator. And what you would do with the numerator is just either add or subtract depending on what it is. In this case, it's subtracting, so it's just 2x minus 4. And then you always want to simplify if you can. And to simplify, it would mean to take everything and factor it. And once it's factored, if there's anything in this that's the same in the numerator and denominator, those can cancel out. So we can take a factor of 2 out of 2x minus 4, and it turns into x minus 2 over x plus 3. There is nothing to simplify or cancel out because they don't have any like terms in the top and bottom. So this would just be our final answer, either in this form or this form would be your final answer. But you would want to factor just in case you can simplify it. In this case, you could not simplify that one. So there's 3 practice problems that are very similar to this that I would like you guys to try. The denominators are the same, so all you need to do is either add or subtract the numerators, factor if possible to simplify, and then come down to your final answer. So I'll give you guys a couple minutes to work on numbers 1, 2, and 3 below. All right, let's go over these answers. All right, so for number 1, we are going to just add the numerators. 5x plus 4x is 9x over 6. And then we can simplify this. It's up to you how you want to do this. Like, you can rewrite 9 as 3 times 3, and you can rewrite 6 as 3 times 2 to cancel it out this way, or you can think of it as just dividing out the factors that they share. We can divide this by 3 and this by 3 and simplify this to be 3x over 2. Either way will work. For number 3, they have the same denominator of v squared minus 5v minus 12, and then the numerator 2v plus 3. And then for this one, in order for things to be able to cancel out, you'd have to factor, and anything that's in the same, the top and the bottom will cancel out. That won't happen here in this problem, so that answer just would be that. And then number 2, we would have c minus 1 all over c squared plus 3c minus 4. But this one can be simplified further because when you do factor the denominator, it will be able to cancel out with the c minus 1 on the top. And that's because c minus 1 times c plus 4 is the factored form for c squared plus 3c minus 4. Since negative 1 times 4 is negative 4 and negative 1 plus 4 is 3. So since I have a c minus 1 on the top and a c minus 1 on the bottom, those cancel, and I'm left with 1 over c plus 4 as my final answer. So as you can see, everything that we've been doing still keeps popping up with factoring and now canceling things out, even though this process is a little bit different. Okay, so that's the easy part. When we have like denominators, we just add or subtract the numerators and then simplify. On the next page, we're actually adding and subtracting with unlike denominators. So the word unlike was not included here. And for these problems, you're not going to be able to just easily add or subtract the numerators because now the denominators are not going to be the same. So now we have to think back to pre-algebra when we were taking denominators. Let's just forget the x's and just think about this 6 and the 8. When you didn't have common denominators, you have to find them. And what you are doing is you're actually finding the least common multiple of the denominators. They call it the LCD, least common denominator. So we're looking at the 6x and 8x. Now, in order for these to be the exact same, we have to change them with multiplication so that they are the same number of x's so that we can actually add them together. So what you're doing, since they both have an x, is since they just both have the same variable, you don't have to worry about the x's. Just look at the 6 and the 8, and the least common denominator is going to be the least common multiple of 6 and 8. So the multiples, what a multiple is you take a number and you just add itself, you just add that number to itself multiple times. So like the multiples of 6 are 6, 12, 18, and so on. Multiples of 8, 8, 16, 24, and so on. So what's the least common multiple, do you think, of 6x and 8x? Yes. So what we are looking for is 24 as the number, and then with an x added to it. So what I have to do is change 6x to be 24x and 8x to be 24x. So what you'll have to do is do this through multiplication. To take 6x and turn it into 24x, we'd have to multiply both the numerator and denominator by what? 4. Yes, we can multiply both of these by 4. And for the other one, 5 over 8x, I'd have to multiply both the numerator and denominator by what? Yes. And we can do that because we're multiplying both the numerator and denominator by those numbers, which they are just making it look bigger, but it's still equal because 4 over 4 really just equals 1. So once you do that, now it's time to multiply everything out, and then you can add. 7 times 4 is 28, over 6x times 4 is 24x, plus 5 times 3 is 15, over 8x times 3 is 24x. Okay, once you have that, this will simplify to be what when we add? 43 over 24x. All right, and then it looks like I can't simplify that, so that would just be the final answer. So that was an example when we just had one single term as our denominator, but in letter B, it's a little bit different. Letter B, we cannot subtract these because one of the denominators is x minus 3, and the other denominator is x plus 2. So with these problems, it's kind of confusing because when you're looking for the least common denominator of x minus 3 and x plus 2, it's not as concrete as if it was just like 6 and 8. You can think of a number that is a multiple of 6 and a multiple of 8 pretty quickly. Thinking of a multiple that's a multiple of both x minus 3 and x plus 2 is kind of confusing because it's not like an actual number. So when you're trying to find a multiple of both things, one of the ways that maybe your teachers taught you in the past is just to take the two things and multiply them. Like you could have taken 6x and 8x and multiplied those together and got a multiple of both from doing it that way. And that's what will happen with these. So when we're trying to find a least common denominator of two terms like that look like this, it would be the product of both of them. So the least common denominator of x minus 3 and x plus 2 is the product x minus 3 times x plus 2. So what that means is I have to take this original problem, 3 over x minus 3 and 5 over x plus 2, and I basically have to multiply this fraction all by x plus 2. And I take this fraction and multiply everything by x minus 3. And I do that because when I multiply the same thing on the top and the bottom, it doesn't change the value because x plus 2 over x plus 2 still equals 1. But I'm doing that so that I can eventually subtract these two things together. Now, it's up to you what you want to do at this point. When I have this multiplication going on, I know that my denominator is now going to be x minus 3 times x plus 2 in any order. And then to simplify the numerator, it's up to you if you want to distribute first and then put it in. I would suggest doing that. So 3 times x plus 2 is going to be 3x plus 6. And 5 times x minus 3 is 5x minus 15. So then when I go to simplify this, we have to be careful because we're subtracting. So we're going to end up doing 3x plus 6 minus 5x minus 15. So I'm showing you all of the steps here so that we don't mess anything up with the negatives. So because I'm subtracting, it makes things a little bit trickier since when you are subtracting a polynomial, that minus sign needs to get distributed to everything on the right-hand side of the parentheses. So it's going to end up being 3x plus 6 minus 5x, and then it's going to end up being plus 15 because this negative is going to get distributed to the negative 15, turning it a positive, over x minus 3 times x plus 2. And then we would have to simplify this further by doing 3x minus 5x. That's negative 2x, and 6 plus 15, that's 21, over x minus 3 times x plus 2. I'm just looking at it really quickly just trying to see if there's anything I can do to simplify it, and there's not. That would just be the final answer. I was just trying to look at the numerator and think to myself, can I factor this so that it can possibly equal x minus 3 or x plus 2 to simplify it further, but it cannot. This would be the final answer for letter B. I feel like the hardest part with these problems is finding the least common denominator and then understanding the method behind it, why you take this fraction and multiply it by this, and why you take this fraction and multiply it by something else. And letter C is an example of that difficulty. So letter C, we have here 5 over 6x squared plus x over 4x squared minus 12x. Now, neither one of these looks the same to me. Like when I'm looking at these two denominators, 6x squared and then 4x squared minus 12x, I'm automatically like, okay, well, the first thing I want to do with these denominators is factor them, just so that I can see what's going on here with this 4x squared minus 12x. So I'm going to factor everything that I can, and then I'm going to find the least common denominator. So 6x squared can't really be factored, but 4x squared minus 12x can be. I can take a 4x out of both 4x squared minus 12x, and I'm left with 4x times x minus 3. So I need to find the least common denominator of 4x times x minus 3 and 6x squared. Here's where things get really tricky, and like even I get confused with this kind of stuff. The least common denominator, what's confusing about the wording of that definition is that the least common denominator is actually not the smallest. It's actually like the biggest number sometimes. So you have to separate all parts and look at the numbers and the variables and see what it's missing so that you can insert whatever's missing so that they're equal. So looking first at the 4 and the 6, if I'm looking at the 4 and the 6, the least common denominator number for just the constants would be 12. So I would need to get the 4 to turn into a 12 and the 6 to turn into a 12. So I know the least common denominator is going to have to be 12 for the numbers. And then again, here's just where it gets confusing. The next part, I'm looking at x and x squared. The least common denominator is actually the largest number of x's. So the largest number of x's that are plain like that would be x squared. And then looking at the x minus 3, the largest number of x minus 3's would just be 1x minus 3. Altogether, the least common denominator for both of these would be 12x squared times x minus 3. So what I need to do is turn both of the denominators from where they currently are at, like 6x squared and 4x squared minus 12x, and turn them into being equal to 12x squared times x minus 3. This is where it gets tricky. So 5 over 6x squared plus x over, and I'm going to put the factored form of this, 4x times x minus 3. So I know that I need to take both of these denominators and turn them into this that I just circled. I need to do that because this is the least common denominator of 4 and 6 is 12, and the least common denominator of x and x squared is x squared, and then the least common denominator of x minus 3, and then there's not another one, so it would just be 1x minus 3. So here's what I'll have to do. Looking at it separately as the 12 and then the x squared and the x minus 3, I know that I need to take this fraction here and multiply it all by 2 since I'm trying to get the 6 to turn into 12. So I know it's going to have to be multiplied by 2. And this denominator already has the x squared, so I don't have to worry about that. It already has the x squared that I need. But I need to take this entire denominator and also multiply it by x minus 3 so that it turns into 12x squared times x minus 3. And then for the other one, I have to fill in the missing parts so that it will equal 12x squared times x minus 3. Right now, looking at just the number, we have a 4, and I need to turn it into 12, so I need to multiply everything by 3. I only have one x here, so I have to multiply everything by an x. And I already have the x minus 3, so I'm good. Now looking at the process, like I multiplied both things by by other things, but I'm basically doing that so that I can get them both to equal 12x squared times x minus 3. If I do that, 6x squared times 2 here, I have 12x squared, all times x minus 3 on this side, plus 4x times 3x is 12x squared times x minus 3. They are now equal, and so then I can multiply the numerators and add them. So 5 times 2 times x minus 3 is going to end up being 10 times x minus 3, which is 10x minus 30. And then x times 3x is 3x squared. Then all I would have to do next is go ahead and add those together. So 3x squared plus 10x minus 30 all over 12x squared times x minus 3. Okay, and then at that point, the last thing that you would want to do, if possible, is factor and simplify, but I would be happy if you got to just this point here. So I would be happy with this answer just like that. But depending on the problem, sometimes they would want you to multiply this out and put everything in standard form. If the problem said put in standard form, then you would want to multiply this out here and get 3x squared plus 10x minus 30 over 12x to the third power minus 36x squared. It really depends on the problem. I'm totally okay with this. If the problem asks, like on WebAssign, the next section they might say put in standard form. You would then have to do that last part there to put that into standard form. Okay, so I feel like all of these problems are a little bit different. Letter D is the last one we'll be able to do today, and this one's different than the first couple of ones we did, because for this one here, the first thing you're going to want to do before you look at any denominators and find the least common denominator or anything like that is factor them. So x squared plus 4x plus 4 can be factored into x plus 2 times x plus 2. And I know that because 2 times 2 is 4 and 2 plus 2 is 4. And then x squared minus 4 can be factored into x plus 2 times x minus 2 because it's a difference of squares, so I can easily factor that one. So then when I'm finding the least common denominator, we have to look at the pairs of things that everything has, and you have to basically make sure that everything has each part for the least common denominator. It's really hard to explain. So basically, this x plus 2 and this x plus 2 are good because they share that. But this x plus 2 doesn't have another x plus 2, so I know that the least common denominator will have to be x plus 2 times another x plus 2, and then times x minus 2. And that's because each pair has to have the same exact components. So we need x plus 2 times x plus 2 times x minus 2 to be able to do that. So for the first one, that means, I am kind of running out of space here. Let me erase this stuff from before. For the first one, if I put it into factored form and set it up for the least common denominator multiplication, this would be x plus 1 over x plus 2 times x plus 2, and then minus 2 over x plus 2 times x minus 2. Okay, so the least common denominator is all this stuff, so you have to look at what it already has and multiply by whatever it doesn't have. So this denominator has x plus 2 times x plus 2, and I need to have the denominator of x minus 2 as well, so I'm going to be multiplying everything by x minus 2 as well. And then this will be minus, this has 1x plus 2 and 1x minus 2, and there's 2x plus 2, so I'll have to multiply everything by x plus 2 over x plus 2 like that. Once I have that, then the denominators are going to be the same, so the numerator will end up being x plus 1 times x minus 2 all over x plus 2 times x plus 2 times x minus 2. Just rewriting it. minus 2 times x plus 2, and then all over. There's so many 2's. Once you have it written down, it's time for the subtraction. So when we're subtracting, we're going to take these x plus 1's and x minus 2's and subtract this here. So it's going to turn into this. X plus 1 times x minus 2 minus 2 times x plus 2, and then all over this stuff. I guess I could just simplify it a little bit by using x plus 2 to the second power. And then in order to simplify this fully, you would have to distribute everything out. Like, we can't cancel anything out right now because of this minus sign here. In order to cancel things out, everything needs to be being multiplied, and this minus sign does not allow me to cancel anything. So what you would have to do at this point here is actually distribute, and then try and factor if possible. So that's kind of annoying. So this is going to end up being x squared, and then plus x minus 2x, so minus x minus 2. And then this is going to be negative 2x, and negative 2 times 2 is negative 4, all over x plus 2 to the second power times x minus 2. What I did here is I didn't show you all the steps because of time, but I multiplied x plus 1 times x minus 2 using FOIL, and then I subtracted this out. I'm running out of space and time, but combining like terms, I can combine negative x and negative 2x and get x squared minus 3x. Negative 2 minus 6 is negative 6 here, all over that. Okay, so that was a lot. These questions are difficult and confusing.